Here is the first example. You can pause this video and read the question and think about what is the random variable here. Can you get the probability distribution of the random variable x by yourself? The random variable should be the number of dollars in payout of dental insurance. Because the number of dollars in payout is uncertain, that's why it is the random variable. Here, I'm going to show you how to get the probability distribution of a random variable x. 0 here stands for you don't need dental repair. If you don't need dental repair, you receive no payout. And we know that the chance that you do not repair is 35%. $100 here stands for you need a minor repair. $1,000 in the last row stands for you need major dental repair. And it is given that the chance of requiring a major repair over the next 3 years is 5%. Remember that the summation of this column must equal 1. So the probability of 0.6 can be calculated as 1 subtract 0.35 subtract 0.05. This equation should equals to 0.6. Notice that all probabilities are between 0 and 1. And then when you add all the probabilities, you get 1. Hence, this is a valid probability distribution. The mean of a probability distribution for a discrete random variable is mu equals to summation of x times px, where the sum is taken over all possible values of x. Sometimes, some values of x that are more likely to receive greater weight, px. Since some outcomes are more likely, it does not make sense to take a simple average, so we give the more likely outcomes more weight. The mean of the probability distribution of a random variable x is also called the expected value of x. The mean reflects not what we will observe in a single observation, but rather what we expect for the average in the long run of observations. This is the second example for discrete probability distribution. You can pause this video and read these questions. Then you should try to get the probability for the number of baits for a randomly select time at the bait by yourself. When a player was out, we denote this event as x equals 0. We know that the probability that the player was out is 74.29%. And 17.04% that the player got a single base. And 5.17% the player got a double. And 0.55% of the time the player got a triple. Last, 2.95% of the time the player will get a home run. Verify that the probabilities give a legitimate probability distributions. It means all probabilities are between 0 and 1. Second, it means all probabilities when added together equals 1. It means when you add all probabilities in this column, it should equal 1. This column, when you add all probabilities in this column, it should equal 1. Second, find the mean of this probability distribution and interpret the mean. So we use the formula here. the mu should equals to 0 times is responded probability value, and so on and so forth. Use the 1 times 0.1704, and so on and so forth. And you can use calculator to verify this result. This number means, in the long run, over many at-bates, the average number of bates per at-bate is 0.4083. This is the fourth example for discrete probability distribution. You can pause this video and try to solve this question by yourself. The probability of selling price is very easy to get. We know that 30% of sales were from the $90 drill. It means when X equals 90%, the probability should be 30%, and so on and so forth. The expected value should be calculated as the 90 times its corresponding probability, which is 30%, and so on and so forth. It means the expected selling price for the sale of a drill is $110 on average in the long run. In your next exam, you are allowed to use calculator to do such calculation.